Hello everyone, my name is Nathan Chi, a software engineering intern here at TwelveLabs, and today I am super excited to be presenting this short hands-on tutorial where together we'll be building a TwelveLabs video RAG agent. And so this project will not only utilize some of the most common agentic frameworks out there on the market today, like LangChain and AWS Bedrock, but we're also going to be leveraging the latest TwelveLabs Marengo 3.0 model. And so this is our latest state-of-the-art multimodal embedding model, and you can see a detailed blog, which I will link in the description, on how it compares to other embedding models out there on the market. And so without further ado, let's get started on building this agent. So to summarize, this agent will essentially transform your video content into vector embeddings with Marengo 3.0. As you can see here in the technical architecture, it'll store it in a JSON file using NumPy, as well as your file operating system operations. And then from there, we'll use NumPy to fetch the top K results using K nearest neighbor back to LangChain, so you have an end-to-end search/recommendation agent for your long-form video content. And so to get started, you can go ahead and first pull this public repository. In order to do that, you can just go to code here, click on copy URL to clipboard to copy this repository's URL. And then from there, simply type git pull and then paste that URL and then click enter. Then it should pull the entire repository onto your local system, onto whatever IDE you are using. And then so it should look exactly like this. So essentially how this project is laid out is that there is a completed folder, which is the completed project where you can look at all the solutions for each exercise. And there's also going to be everything else that's not included in the completed folder, well, essentially what we'll be working on today. You can see that there's a DB folder representing our database, which is just gonna be a JSON folder. Typically in production, this would be an in-memory database, something like Redis or AWS Memory DB. And then from there, you can see that we have a set of tools. And then so this tools folder is essentially just going to be a package that exports append to JSON, create video embed, and text RAG. So these are the three tools that our agent will have access to in order to essentially take action. Then we have a virtual environment for Python. We also have a videos folder. This is where you can contain all your local videos that you want to be embedded with Marengo 3.0. We have a .env folder or file, and this will contain all of your API keys to access the AWS console as well as your TwelveLabs indexes. And then so this is essentially how you are going to format that .env. I won't reveal mine just for security purposes, but be sure you create the proper AWS account and TwelveLabs account before proceeding. And then from there, we have this main.py file, which is going to be the main agent loop that you can interact with. So you can see that there's a while loop here in _agent_loop. There's a while loop that essentially activates that whole prompting process where it'll continuously prompt, respond, prompt, and respond. And then here in main, we are creating the agent. Here I'm using the AWS Bedrock integration, and I'm choosing the Claude 3.5 Sonnet model on AWS Bedrock. And so great. Now that we have a basic understanding of how this folder structure works, we can actually begin the tutorial. So go ahead, navigate to the virtual environment, and you can go ahead and then run the command pip install -r requirements.txt. This will essentially just install all the dependencies listed here. So TwelveLabs, LangChain, Python.env, etc. And then your environment will be set up. And then from there, taking a look at the code, you'll be able to see some of these to-do exercises. So to-do exercise number 1 will be in create video embed. First exercise is going to be creating video embeddings using TwelveLabs API. You can see that the starter code already includes all of the logic to convert a video file path all the way into a base 64 video string that you can directly pass into the API. The second exercise is going to be in text_rag. And then again, you're creating another embedding, albeit this time you're creating a text embedding. So this text embedding will be used to be compared to your video embeddings to find the closest search. And lastly, you'll be implementing in exercise 3 the actual cosine similarity algorithm for k-nearest neighbor search. So the formula is listed here, and some of the suggested NumPy functions are here. And so yeah, and essentially what happens is that once that cosine similarity algorithm is done, you save it in the similarity variable, and then it'll get pushed onto a heap that will then do all the necessary logic of returning it back to the LLM agent for you. And so now I'll give you a few minutes. Feel free to pause the video at this point to go ahead and complete the exercises to the best of your ability. Again, it doesn't have to be perfect. If you do get stuck, feel free to navigate to the tutorial exercises section of the GitHub repository and click to see the solution. Hey, great. So I hope you guys had fun sort of going through those exercises. I'll now just go ahead and click to see the solution and sort of explain out how each of these solutions or exercises work. And so for exercise number 1, which is the create video embed, essentially here we're calling the new embed.v2 API endpoint. And then so essentially using your TwelveLabs client that you created up here, so it connects to your TwelveLabs playground via the TwelveLabs API key. It'll then call the embed.v2.create. And then from there, you simply have to specify the input type, that being the video, the specific model name. In this case, we're using Marengo 3.0, and then have a video input request here and pass in the base64 string. So exactly where to find this content will be on our SDK reference. So as you can see here, if you scroll on the Python SDK all the way down to create embeddings v2, scroll down to sync embeddings, you can see that that exact code is right here. And so pretty straightforward in regards to creating the video embedding. For exercise 2, the text embedding is very much the same. Essentially, again, we are calling the .embed.create this time. We're passing in the text that we want to embed. And then again, we're just doing some very quick validation to ensure that the SDK has returned something to us. Now, the really interesting part is actually going to be implementing this cosine similarity. So cosine similarity, just to give a little bit of context, is going to be the algorithm that determines how close our text embedding is to all of the vector embeddings inside our database. And then so the closer it is, that means we have a very good match. The farther it is based off of this algorithm means that our text doesn't really line up with that specific moment within our video. And then so essentially how we implement that is by taking the dot product of our text embedding and video embedding, and then dividing that by the length of the text embedding times the length of the video embedding. And then so here, essentially what we're doing is we normalize the text embedding and the video embedding. The reason we normalize this is to take away the magnitude, as cosine similarity is a angle-based algorithm. So we only really want to consider the direction. And then so we take the product of those two using mp.dot, dot product in this case. So text embedding times video embedding array. And then we take that product and we divide it by the length of the text embedding times the video embedding. And just like that, you have just completed the project.